Hello everyone. We are going to talk about angles in a triangle today. And I hope at this point you remember that there are 180 degrees in the measure of all of the angles of a triangle, meaning if you look at this picture at the top of the page, I'm going to mark the angles A, B, and C. You should hopefully remember that the measure of angle A plus the measure of angle B plus the measure of angle ACB, meaning the interior angle, has to equal 180. So subtracting 32 and 38 from 180, you should find that the interior angle C has a measure of 110 degrees. And again, knowing that there are 180 degrees in a line as well, that leaves us with 70 degrees for angle X. Now the table below that picture has 4 types of triangles that I want you to consider drawing and see if you can come up with a conclusion for each of them. And for the right triangle, you see a triangle ABC with a right angle at B. Conclusion is every right triangle has one right angle, in this case it's B. And then knowing that there's 180 degrees in a triangle, that leaves us with 90 degrees left for A and C, meaning angle A and angle C are also complementary. When we're talking about the exterior angles of a triangle, we're talking about this angle out here similar to the problem we did to start class with. Angle 1 is an example of an exterior angle, and if you didn't notice it up at the top, because of what we know about 180 degrees in a triangle, all 3 of these add up to 180 degrees. I'm going to mark this one as 4. 2 plus 3 plus 4 would equal 180. 1 plus 4 would also equal 180. So it turns out that the measure of angle 1, the exterior angle, is going to be equal to the measure of angle 2 plus the measure of angle 3. Bringing you back to the top picture, again, if you notice here, 32 plus 38 equals 70. And that will always happen because of the relationship between 180 degrees in a line and 180 degrees in a triangle. And if I did a really quick little mini proof here, I'm going to write it off to the side here and then move on. We know that angle 2 plus angle 3 plus angle 4 equals 180. And we know that angle 1 plus angle 4 equals 180. So doesn't it make sense, since both of these equations are equal to 180, and they both have a 4, that 2 and 3 are equal to 1? I hope that makes sense. Now the proper way to say that is to say the sum of the 2 remote interior angles, so by that I mean 2 and 3, we call them remote because they're further away from this angle 1, is equal to the measure of the exterior angle. That's known as the exterior angle theorem. We'll talk about that in a little more detail in days to come. Now an isosceles triangle, I bet you've heard of that before. Isosceles means it has 2 congruent sides. So in this case here, if I have triangle ABC, and notice that those tick marks that I've used mean that those 2 sides are congruent. That's a way of denoting on a picture that you have congruent sides. And what you may not know about is that not only does it have 2 congruent sides, an isosceles triangle also has 2 congruent angles, meaning angle A is congruent to angle C in this particular picture. Angle A and angle C are known as the base angles, and angle B is known as the vertex angle. And lastly, I'm sure you've heard of an equilateral triangle, which again, notice that I've marked every single side congruent, which means all 3 sides are congruent. AB is congruent to BC, which is congruent to AC. And now that we've talked about this above, it may not be a surprise to you that also all of the angles are congruent. Angle A is congruent to angle B, which is congruent to angle C. And again, knowing that there's 180 degrees in every triangle and every angle is the same, probably doesn't take too many calculations to figure out that each one of those measures are 60 degrees. Okay, let's do some problems. Now, this first set of exercises I think are pretty straightforward. So again, as always, I recommend you pause the video and see if you can get your way through these without any help from me. Notice in number 1, we are looking for angle 1, which is this guy here. I hope you noticed these little tick marks to let you know that those two sides are congruent, which means those two angles are congruent. So if one is marked as 75, the other one is 75, and subtracting from 180, we end up with the measure of angle 1 is equal to 30 degrees. Remember, angle 1 is called the vertex angle. Taking a look at number 2, where we know the vertex angle is 72 degrees, and again we have these two sides marked as congruent, well, that means these two base angles are the same. So if I have 180 degrees and I subtract 70 from it, that leaves me with 110 degrees for the remaining two angles, and being that they both have to be the same, I'm going to cut that in half and say the measure of angle 2 is equal to 55 degrees. And keep in mind, it doesn't take a whole lot of calculation to add up 55, 55, and 70 to make sure you have that 180. Okay, let's try number 3. Now in number 3, if you remembered what we talked about on the previous page, you might be able to do this very, very quickly and say, angle 3 is an exterior angle to these two remote interior angles, so it must be equal to the sum of those two angles, meaning the measure of angle 3 is equal to 120 degrees, 80 plus 40. But guess what? If you forgot that, you're still going to be okay because you know there's 180 degrees in every triangle. So if 40 and 80 add up to 120, that leaves me with 60 degrees for this angle. And then subtracting that from 180, I'm still going to get 122 degrees. So just keep in mind, the more you know, the less work you have to do. Taking a look at number 4, I see this angle of 115 degrees, and I see a line. So adding that to 180 degrees, I know that's 65. This symbol right here, the right angle, that's 90. So subtracting 90 from 180 and then 65 from that leaves me with the measure of angle 4 is 25 degrees. Again, that's 180 minus 90 minus 65 to get that 25. Now those first 4 are pretty straightforward, and just like with everything we do, it starts out kind of simple and then the pictures get messier and messier as we go. Taking a look at number 5, you still see that same isosceles triangle, but it's tipped over on its side. So if this side and this side are marked as congruent, the base angles would be those two. So right off the bat, I know the measure of angle 5 is 68 degrees because it's going to be equal to the other base angle. And then subtracting from 180, that's 68 and 68, that leaves me with 44 degrees for the measure of angle 6. And then again, noticing that I have a linear pair here, subtracting 44 from 180 tells me that the measure of angle 7 is 136 degrees. And for the last one on this page, now don't be afraid to just find everything that you can find. We're going to get pictures that are very messy. And I'm looking at this one right in front of me, and right off the bat I see that 95-degree angle that makes a linear pair with this one. So I know that angle right next to it has to add to 180, so I know that one has to be 85. And knowing that this is 85 and this one's 64, subtracting these two angles from 180, I'll be able to figure out the measure of angle 9. And when I do that, I get 31 degrees. Notice that I found the measure of angle 9 first, and that's okay. There's nothing magical about the sequence. I kind of go with what you see. And lastly here, knowing that this is a 90-degree angle in total, both of these pieces make up 91, then I know that this one here plus the 31 has to add up to 90. So that leaves me with 59 degrees for that angle, because 59 and 31 adds up to 90. And then again, I have yet another triangle here. This one right here, those angles will also add up to 180, so adding up 59 and 95 and subtracting that from 180, I have 26 degrees. Now, it may be worth your while to just really quickly in your calculator, just double check that every place you see a triangle, so in this case, this triangle here, does 26 plus 59 plus 95 add up to 180? It should. 31, 85, 64, does that add up to 180? And lastly, what about this big triangle? If you add up this angle 26 and 64, that's 90 degrees plus this 90, every single triangle adds up to, the angles of every single triangle adds up to 180 degrees. Good way to check yourself. Let's move on. Okay, in these next set of exercises, notice that there are no pictures, which makes it a little bit more challenging. But you know what? You can get rid of that added challenge really quickly by drawing your own picture. So I'm going to start in triangle ABC. Now notice when you draw the picture, remember that when you draw the picture, it's likely not to scale because we are just drawing with the information that we're given, and it doesn't matter. It's really just to use a guide. So the measure of angle B is 3 times as large as angle A. So I'm going to mark angle B as 3x and angle A as x. An exterior angle at C measures 140 degrees. So I'm going to extend this line and put in 140 degrees as the measurement of the exterior angle, which I hope it won't take too much calculation to remember that this one here has to be 40. And now you have a couple of different ways that you can solve this. If you remember that the two remote angles, the measure of the two remote angles equals the measure of the exterior angle, you could solve it that way, and you end up with 4x equals 140, or x equals 35 degrees. And if you didn't remember that, I'm going to go off to the left side here. I could have said x plus 3x plus 40 equals 180, because I know there's 180 degrees in every triangle. And cleaning that up, you might see something familiar. 4x plus 40 equals 180. And subtracting 40 from both sides, you end up with 4x equals 140, which, if you notice, was the same thing we had over here. And in any case, x equals 35 degrees. The more you know, the more options you have. Let's take a look at number 8. Once again, start by drawing a picture. We have triangle CAT, and I'm going to label it as such since it says CT is extended to S. And it's telling me that the measure of angle CAT is x squared minus 3x. So I'm going to squeeze that in there, x squared minus 3x. And the measure of angle ACT is 6x plus 20. And the measure of angle ATS is 2x squared minus 5x. Now again, there are a couple of different ways that we can approach this. I'm going to go right into the exterior angle theorem and say x squared minus 3x plus 6x plus 20 equals 2x squared minus 5x. And then I'm going to clean this up as best as I can. I'm going to have x squared plus 3x plus 20 equals 2x squared minus 5x. Now remember, I hope when you're solving a quadratic equation or an equation with an x squared in it, you want to set it equal to 0. So I'm going to actually subtract everything over to the right side. And when I do that, I'm going to have 0 equals x squared, because I'm subtracting x squared from both sides, and then I'm going to subtract a 3x. Maybe I'll write that in. I will have minus 8x minus 20. And now hopefully you remember your algebra. I'm going to factor this equation into two binomials, which will leave me with, I'm looking for numbers that add to a negative 8, multiply to a negative 20. I'm going to go with 10 and 2. And I think I want a positive 2 and a negative 10, to give me what I'm looking for. Setting each factor equal to 0, I have x equals 10 and x equals negative 2. And even though x is a negative 2, both of these answers are acceptable. If you go back in and plug them in, you do get positive answers for all of those angles. So both answers are okay. If you're a little rusty on the algebra there, don't worry too much about that. We'll get better and better with the algebra as it comes up. Okay, let's take a look at number 9. And once again, see if you can draw this picture. Isosceles triangle ABC, where C is the vertex angle, which tells me that AC and BC are the sides that are congruent. If the vertex angle C is 20 more than twice the base angles, I'm going to call each of the base angles x. And I think you know how to set this equation up. X plus 20 plus 2x will equal 180. And doing some pretty simple algebra, especially compared to the other one, we end up with 4x equals 160, x equals 40. And notice that in this case, it doesn't say find x, it says find the measure of each angle. So make sure you go back in and figure that angle A is 40, B is 40, and then you can kind of mentally check yourself. 20 plus 2 times 40, 2 times 40 is 80, plus another 20 will give me 100, and double check that all three of those add up to 180. Okay, let's take a look at number 10. And in number 10, you have a right triangle where angle D is the right angle, and F is 12 degrees less than twice the measure of E, so I'm going to call E X, and F is 12 degrees less than twice that, so how about 2x minus 12? And you could set this up a couple of different ways. You could say 2x minus 12 plus x plus 90 equals 180, or you could just set these two angles equal to 90 degrees, because we talked about how we knew they would be complements. All ends up working out the same. Doing some, again, pretty simple algebra, you end up with 3x equals 102, and x equals 34. And again, don't forget to go back and say, that means this angle is 34, and this one would have to be 56. 2 times 34 is 68, and 68 minus 12 would give you 56. All right, let's move on. Now these last few exercises are a tad more challenging than the ones we did on the previous page. Again, pause the video, try it for yourself. Notice all the markings that you see here for congruence. These two sides are congruent, those two sides are congruent, and see how you do before you double check your answers. To start off in 11, notice that you have a vertex angle of 56 degrees on this big isosceles triangle, which means I have 62 degrees for this entire angle, and 62 for the entire one over there, which is a little bit bigger than angle 1. So now I'm going to redraw that other little triangle. And if I pull it out, it might be a little bit easier to see that I have this 62 degree angle right here. And notice that these two sides are also marked as congruent, which means this angle is also 62 degrees, which leaves me with the measure of angle 1 is 56 degrees, because if you add up 62 and subtract that from 180, that leaves you with 56 degrees right there. Now for the number 12, there's really a lot of different ways to go about doing this. I'm going to recommend you find the angle that I marked in blue, either one to be honest with you, to get started. When you do, you will see that this angle here is 65 degrees. And then again, reminding yourself that there's 180 degrees in every triangle. I have a 65 and a 35, which leaves me with 85 degrees for this angle down here. And I'm just going to keep finding angles, knowing that there's 180 degrees in every line. I know that the angle right adjacent to that 85 degree angle has to be 95 degrees. And I'm going to zoom back out a little bit. I'm going to grab my highlighter, and you see this triangle here. Notice that you have two of the three angles there. You have a 34 degree angle and a 95 degree angle, which leaves us with the measure of angle 2, subtracting 95 and 34 from 180, 51 degrees for the measure of angle 2. And again, never a bad idea to go back through and fill in all the rest of the angles if you have time to see if everything works out. You should find that every line has 180 degrees and every triangle has 180 degrees. Now for this last one, I'm going to give you a little hint, and I'm going to leave you to figure it out on your own. You may not know that because you know enough about points and lines, you are actually allowed to draw in any line you want to. So if I drew in a line like that, notice that I now have a triangle, because previously I didn't have a triangle. And that might be enough information for you to figure out the measure of angle 3. I got 127. See if you can get the same answer as me, or maybe you did it a different way. Maybe you drew in a line that looks like that. If you have any questions, email me, homeworks@Schoology.